Hello and welcome to Morse's Math Morsels. And here we have the question, what is the least multiple of 2013 whose only digits are zeros and ones? That is, if you were to go far enough along in the 2013 times table, and I chose 2013 because that's the year this video was made, would you reach an entry which contains ones and zeros and no other digits? Is it even possible? And yes, there are such numbers with ones and zeros. So are there any strategies for finding such a number? Well, we can consider the factors of 2013. Maybe that will help us determine how many ones there will have to be and maybe how many zeros. If we factor that number, we get 3 times 11 times 61. So the 3 and 11 especially can tell us about the nature of 2013. Because 3 is a factor, we're going to need a number of ones and not multiple with the ones and zeros, in which the digit 1 occurs in clusters of 3. There can be 3 ones or 6 ones or 9 ones, but the ones must be 3 at a time. As for the 11, there's a more complicated divisibility rule, and that is if the sum of the odd placed digits and the even placed digits differ by 0 or multiple of 11, then the whole number itself is a multiple of 11. And finally, 61, that's a prime number, and there's no easy clear-cut strategy for helping us determine the zeros and ones digit arrangement for 2013. So an approach to finding that is called brute force. I just try to start with 2013 and start listing its multiples. 4,026, 6,039, 8,052, etc. But if you do that with most numbers, you're going to find that I just keep running into a mishmash of digits other than zeros and ones. You'll have 3s and 6s and 7s and everything else getting in the way. So I used a computer program to generate the final number, and luckily it is pretty small. Some such multiples could have 15 or 20 or 25 digits. In the case of 2013, it happens to be fairly small. And I'll pause for those of you who want to figure it out in your calculators or your own programs before I write down the solution. Okay, ready for the solution? Here it comes. One million 101,111 is the least such multiple of 2013. In fact, it equals 2013 times 547. So if you were to do that multiplication in a calculator, you should get this product. Does it fit our properties of the 3 times 11 times the 61? Well, are there 6 ones? It looks like there are 6 ones. 1, 2, 3, 4, 5, 6. So there are 6 digits of 1, so that fulfills the 1 requirement. As for 11, I'm going to look at the odd numbered digits and the odd numbered places, every other one. Well, we have 7-digit number. There's our 7th digit place, our 5th place, our 3rd, and our 1st. If we add up these ones and zeros, 1 plus 0 is 1, plus another 1 is 2, plus another 1 is 3, so that total is 3. And then for the even numbered places, the 2nd place, the 4th, and the 6th, add up these ones, 1 plus 1 plus 1, that's also 3, so divisibility by 11 is assured. Did the number have to end with 0? No, because the original number, 2013, ends with a digit 3, and if you have a number ending in a 1 or 3 or 7 or 9, the multiple itself may be odd and the 0 ending is not required. In another video, I'll give a few illustrations where such a multiple with just 1's and 0's must end with one or more zeros. Thanks for viewing.